All right, Honors Algebra 2 and Algebra 2 eventually. This is your matrix, the Chapter 3 Part 2 test review, the matrix test review. Honors Algebra 2 will be taking this test on Tuesday the 1st, Wednesday the 2nd. Algebra 2, you take it the week after, okay? So that's what we got so far. So this first page here will be pretty easy. No calculator needed. Given the augmented matrix, write the system that corresponds to it. Here we got x, y equals the number x, y, z equals. Then you got your constants there. So 5x minus 3y is negative 9. 2x plus 5y is 17. Here, don't let those zeros fool you. 2x minus 3z, there's no y, equals negative 7. No x, negative 2y plus 3z is 8, and 5x minus 6y, there's no z's, equals 12. Okay, write the system as an augmented matrix. There we go. So your answer for 3 and 4 looks kind of like how 1 and 2 are presented. Do use the matrix, like those brackets. I couldn't when I typed this up for 1 and 2, but do use them for 3 and 4. All right, let's talk about 5. 5 just corresponding to the negative 5 can be added to the negative 2. The 17 is added to the negative 10 and so forth. All right, number 6, just corresponding 5 minus a negative 4 plus 2 is 11. Negative 1 minus 1 is a negative 2, but add 3 to it, you get 1. That's how we got those answers. 7, we're going to distribute that 3. Everything in that first matrix gets multiplied by 3, plus everything in the second matrix gets multiplied by 5. Then we add the two matrices together. No special calculator needed on this whole first page. Everything in the first matrix is multiplied by negative 9. Everything in the second one is multiplied by 4. And everything in the third one is multiplied by 5. And then we add them up. All right? Again, this plus this plus this is that. This plus this plus this is that. Let's talk about number 2. You can use a calculator here. So the determinant of a 2 by 2 is just the difference of the cross products. Negative 4 times a negative 2 is 8. Minus 4 times 1 is 4. Currently, I plan on showing you how to use the calculator in class. If things change, we'll go from there. So A inverse is 1 divided by the determinant of this kind of flipped matrix. Negative 4 and negative 2 switch spots. 1 and 4 become the opposite values. Again, you can use your calculator for everything there. We'll talk about that more later. Multiply the matrices. Again, you can use your calculator there. A times B. I'll help you out on Monday the 30th if you need help with that. 13 is a 3 by 5, so A14 means what is in the first row, fourth column, and that is 0. A32 means what is in the third row, second column. So hopefully I said that right the first time. Row by column. What is in the third row, second column? That's 26. You need to change this to A35 because there's not a fifth row. What is in the third row, fifth column? 11. What value of x, y, and z will satisfy the matrix equation? 32 plus negative 11 corresponds with 4y minus 13. 10z plus 15 corresponds with 27. And the x minus 3 plus a negative 3x minus 2, that equals 17. Those are your answers. All right, let's talk about this next page. Solve for x. You're given matrix A times matrix x equals b. So you just do x equals A inverse b. So you're going to get a 2 by 2 here, okay? 4, you just subtract. Matrix x is all by itself, so you subtract this matrix from that. And there we get that answer. 17 here, you're going to add the matrix, this one, to this one. 2x is equal to that. And then if double your matrix is that, just divide everything in this matrix by 2. And x, which is a matrix, is that 2 by 2. 18 through 20 is where you're going to use A inverse B. Again, you need to show your work like this. Matrix A, the coefficients, 2, 3, 4, and then so forth. Matrix X is what you're solving for, X, Y, and Z, equals matrix B. Those constants, 3, 3, 6. So A equals A inverse B. We did that in class. You're going to get a 3 by 1. So do the same thing on 19. Be careful on 20. There's some zeros involved. All right, in fact, so on 20 here would be matrix A, 0x, 4y, 5z, 3x, negative 2y, 0z, 1x, 0y, 3z. That is matrix A. Matrix X is x, y, z equals B, 4, 0, negative 8. So X is A inverse B. X is a 3 by 1. Yeah, so there we go. Type in your calculator, A inverse B. Okay, I would use the calculator here. I would just type in and edit matrix A, B, and C. They're all 3 by 3s, and then in your calculator you would do 2 times A times B. Here you can just do this one by hand if you want. You can also use a calculator. This is everything in A times 7. This is everything in C times 3. Again, if you've already edited it, you might as well do 7A minus 3C. And then I would do matrix C times matrix B. On 24 here, so A is a 3 by 3 matrix and B is a 3 by 1. Can you add a 3 by 3 and a 3 by 1? You cannot. You have to have the same exact dimensions to add or subtract matrices. So that A is not defined. B, can you multiply a 3 by 3 with a 3 by 1? You can multiply them, and AB would be a 3 by 1 matrix. C, can you do B times A? Well, a 3 by 1 and a 3 by 3, those inner numbers don't equal, so you can't multiply. That is not defined. And D, can you do a 3 by 3 minus a 3 by 1? No, to add or subtract matrices, you have to have the same dimensions. That is not defined. All right, use matrix A, B, and C to do the following. I would, we're going to have to pause here because we're getting a call.